Hi everybody. In this lesson we want to look at a quadratic maximization problem. So here's an example. Ginger's designing a garden and she's fencing in a rectangular region using the side of her house as one side of the rectangle. So here's her house over here and she's going to only have to fence three sides and then the garden will be in this area. Alright? And the question is, what's the maximum area she can enclose if she has 40 feet of fence? And then what dimensions would yield that maximum area? Well, when you have a problem like this and you're not sure what to do, one thing you can do is just start plugging in some numbers and imagine what it might look like. All right, so I've got 40 feet of fence, and I'm going to have to divide that into two sides and a length. All right. So let's just start off and let's let each of these sides here be x. We'll let x equal the width of the garden. Alright, and then let's do this. Let's just make a little table of values. Let's just start writing down some things here, some numbers, and let's just see what this might look like. Get an idea of this. All right, so I've got I've got a width of the garden. That's my x value, right? And then I've got a length, and then I've got an area. All right, the area will be the width times the length. Well, let's just imagine that Ginger made a rectangular garden that was like this. She wanted it really skinny, she just wanted it all real close to her house there. And let's just suppose that there was 1 foot here and 1 foot here. Well, that uses up 2 feet of the 40 feet, right? So I've got a width of 1 foot, and then the length is going to be 38 feet. And so the area of that would be 38 square feet. Okay? Well, she could also make it a little bit wider, maybe something like this. All right, so let's suppose that it was 2 feet on each end. So you'd use up 2 feet and 2 feet. So if the width was 2 feet, then you're going to have to subtract off 4 feet from the 40. So that would leave you, what, 36 feet? And then the area would be the width times the length, which would be 72 square feet. All right, and we could do that. We could, if we had 3 feet on each side, you could make, imagine the one that's here is 3 feet and 3 feet. Then you would have 40 minus 3 times 2 feet. That gives you what? 40 minus 3 times 40 minus 6 feet is 34 feet. So you'd have 34 feet for the length here, and then you'd have 3 feet and 3 feet, and that adds up to a total of 40 feet. So whatever 3 times 34 is, I think that's 12, that's 102 square feet. And you can see that you're going to get more and more. Well, on the other end of the spectrum, she could also maybe have a garden that was like this. And let's just suppose, now notice that the very biggest distance she could come out here would be 20 feet, right? If she went out 20 feet and then back 20 feet, that'd use up all of the 40 feet of fencing she has, and she wouldn't really have any area then. So let's say she just went out 19 feet on each side. That'd use up 38 feet of her fencing, and then she'd just have 2 feet for this length here. So if each of the widths was 19, then the length would just be 2. 19 and 19 on each side is 38 and 2. So 19 times 2 is 70. Let's see, 19 times 2 is 38 square feet. Okay? So you can see that somewhere between here, there's going to be a maximum amount of area. Well, notice if I were to keep going here, if my width is x, then I'm going to have to take 40 feet and subtract off 2x, an x for each of the widths that goes back to the house there. And so I know my area is going to be x times 40 minus 2x. So this gives me a function for the area. The area is going to be x times 40 minus 2x. And notice that if x is 2, I got 2 here, and then 40 minus 2 times 2, that was the 36. All right, if x was 3, I'd have 3 here for the width, and then 40 minus 2 times 3, that was the 34 feet for the length. Well, I can do that for any value of x. That's what algebra is all about. So notice that I can rewrite this. This would be 40x minus 2x squared. Or let's write it this way. Let's write it as a negative 2x squared plus 40x. And then you can see, oh, this is a quadratic equation. And I know that when I graph it, it's going to be a parabola, and I know it's going to open down. So I should have in mind a picture that looks something like this. And notice also from right here that my zeros of this are going to be x equals 0. If I plug in 0 for a width, then I'm just going to have 40 feet along the edge of the house, and that won't have any area. And likewise, if x is 20, it's also going to be 0. That would be when I went 20 feet down here and 20 feet back, and there wouldn't be any fencing left to have any area in the garden. You would have used it all up. All right, so those are my zeros, and because this is opening downward, I know that that parabola is going to come up and then come back down through that other 0. All right, well, from right there, you might guess, you might remember that the vertex is always halfway between these x-intercepts. All right, so it turns out that sure enough, the vertex is going to be at 10. And then all I would need to do is find out what the maximum area is going to be. So let's do this a couple ways. Let's go ahead and rewrite this. Let's go ahead and factor a negative 2 out of this and complete the square. X squared minus 20x, and there's nothing over here to push off to the side. I'm going to take half of the negative 20, which is 10, and square it. Now, when I add 10 squared to complete the square in here, remember I'm actually multiplying by negative 2. So over here, if I subtracted 2 times 10 squared, I'm going to have to add 2 times 10 squared to compensate. Okay? So my area is going to be negative 2 times x minus 10 squared. When I complete the square, this is a perfect square, and I know I have to square x to get x squared and square 10 to get 10 squared. And the middle term will be this times this doubled, and that works. And then I get plus 200. All right? So this tells me that the parabola has been shifted 10 to the right, and sure enough, that's what I got from just looking, figuring the vertex had to be halfway between 0 and 20, and up 200. So there's the number I'm looking for. I know the maximum area is going to be 200. Now I can also see that over here. If I were to come over here and put in 10 for the width, I'd have 10 feet, and 10 feet is 20 feet, and that leaves 20 feet from the 40 for the length, and 10 times 20 is sure enough 200 square feet. And this is saying that that's going to be the maximum. Now I could also have, once I was to this point right here, or right here, either one, I could put a big or. The maximum occurs at the vertex, and that's going to be true of any quadratic equation that's opening down. If it was opening up, the minimum would occur at the vertex, but the maximum occurs at the vertex, which is always at x equals negative b over 2a. So in this case, I know that the maximum is going to be at x equals, what's negative b? Well, b is 40, so that would be a negative 40. A is negative 2, and sure enough, negative 40 over negative 4 is 10. And then once I know, so the maximum area has to be the area function that we have up here evaluated at x equals 10. And that would be, negative 2 times 10 squared plus 40 times 10, and that's going to give you a negative 200 here plus 400 here, which is again, 200 square feet. All right, so one last thing we might want to do is just let's try it. Let's what happens if I put in here like 9, or if I put in here 11? Well, if my width was 9, then I'd have 9 and 9, that makes 18. That would leave 22, wouldn't it? And 9 times 22 on my calculator is 198. So notice that's just a little bit less than the 200. I could also try it at 11. Need a little more room here. It's kind of in the way, isn't it? Well, I'll put it down here. So if x was 11, then I would have 11, and 11 is 22, and that would leave me 18 for the width. So if I had 11 times 18, I wonder what that area would be. Let's try it. So 11 times 18 is, well, how about that? It's also 198, right? So it's certainly reasonable to believe that when x is 10 and y is 20, 200 feet, that's as big as it's going to get. And that would be the maximum area is 200, and it's going to occur when x is equal to 10. So if I go 10 here and 10 here and 20 here, that's as big an area as I can possibly enclose for the garden when you have one side against the house like that.